Hey everyone, Mr. Kaczynski here, going through the IXL skills in Algebra 1. Section double D, absolute value functions. Skill 3 today, domain and range of absolute value functions when just looking at their equations. In the last video, we did domain and range while looking at their graphs. Hopefully between that skill and the skill prior, we've learned enough about this where we can start looking at things. All right, so number one, what's the domain of this function? Now we pretty much saw, well, think about domain as all the possible values you can put in. Can you think of a value of x that we can't take an absolute value of? I can't, because it's all real numbers, and that's pretty much, I can't think of many instances where we would have an absolute value function that wasn't all real numbers for the domain. Now the range is a little bit different, okay? These are the possible outputs. If I put 0 in here into this equation, the absolute value of 0 is 0. And then if I put 1 or 2 or 3, the absolute value of those are 1 or 2 or 3. So it goes up from there. Now as I go down into the negatives, absolute values still turn out positive. So they're always 0 or greater. So that's what this says right here. Values of y such that y is greater than or equal to 0. You'll never take an absolute value of something and get less than 0. So that's the basic gist of it. Now we're going to jump into domain and range of these. Okay, this one really isn't all that much different. Okay, first of all, domain is all real numbers. Okay, so we can get rid of this and we can get rid of this. Domain is definitely all real numbers. And the same thing on this. Just because you're multiplying x by 2 doesn't mean that the outputs are going to change any. If we put 0 in, we get 2 times 0, which is 0, and the absolute value of that is 0. That's our minimum value right there. If we put negative 1 in for x, 2 times negative 1 is negative 2, and the absolute value of that is positive 2. So you're never going to have something less than negative 2 either, okay? We're only going to have all real numbers for our domain, and our outputs are always going to be 0 or greater. Y such that y is greater than or equal to 0. All right, again, domain is all real numbers. There's not any values of x that I can't substitute into that, okay? So domain is all real numbers. So that narrows down our choices a little bit. Maybe that helps us. The range is, again, it doesn't matter that we multiply by negative 2. It doesn't matter that we add 8 to this. If I plug in negative 4, though, for x, negative 4 times negative 2, I'm sorry, how about positive 4? Positive 4 times negative 2 would be negative 8, and then negative 8 plus 8 would be 0. The absolute value of that is 0. All right, we're still not going to get any negative values. It's still going to be greater than or equal to 0. All values of y such that y is greater than or equal to 0. Domain. Definitely all real numbers again, okay? We can take the absolute value of any number. Outputs. Again, we can get 0 for this because if we put a 0 in for x, 0 times the absolute value of 0 is 0, and 0 times 4 is 0. So we can have greater than or equal to 0. Seeing a trend. Don't worry, I'm going to change it up here. Here, now we've got some things that change things. This negative 4 on this one and this positive 3 over on this one. Okay, if you think back to quadratic equations, and that's that number hanging off there is like how much it's been translated vertically. So this has been translated 4 units down. All right, so even if this comes out 0 in the absolute value, once you subtract 4 from 0, you're going to get negative 4. And then it's going to go up from there. So the range is all values of y such that y is greater than or equal to negative 4. Whereas with this one, say x is 0. The absolute value of 0 is 0. 0 times 3 is 0, and 0 plus 3 is 3. And then as we plug in other values of x, it's only going to go up from there. So this is all values of y such that y is greater than or equal to 3. We can get 3 and we can get bigger, but we're not going to get any numbers out of this function that are less than 3. Just a couple more. All right, seems like there's a lot going on with this one, okay? But again, the only value that really matters in this case is this one. All right, because we can get 0 for all this stuff. 0 in the absolute value quantity, multiply it by 8, we get 0. And then when we subtract 7 from it, it's going to be -7. But every value we get from there is going to be greater than or equal to that. So first of all, let's get rid of these ones that don't have all real numbers for the domain, because we know the domain is all real numbers. And then it's going to be greater than or equal to -7. All values of y greater than or equal to -7. -7 is the smallest output we can get, and from there it'll go up. Now, here's where things change, because there's two things that matter here. Number one, this -3, and number two, this negative sign right here. Okay, those two things matter. So say we put 0 into the absolute value quantity. 0 times -2 is 0, 0 minus 3 is -3. All right, let's get rid of the choices that aren't all real numbers. But is it greater than or equal to -3, or is it less than or equal to -3? Let's throw another value in for x, like 1 or -1. Either one, when we take the absolute value of it, we get 1. 1 times -2 would be -2, and -2 minus 3 is -5, which is a value less than or equal to -3. So it's actually going to go down from -3 after that. All right, so we're just using some logic about absolute value functions in order to determine their domain and range. All right, good luck with that one. Let me know how it goes in the comments.